and we had the privilege of working with the Volunteer Center of North Texas. What we did was create models for optimizing their processing procedure. So a little bit of background about the Volunteer Center is they're one of the largest volunteer organizations, and they provide volunteers for other nonprofits and help them be successful. What we're going to focus on is their discounted goods depot, and this is a picture of their Dallas location, which is where we worked. And a background of the discounted goods depot is that they provide nonprofits and others listed above with items that are half the price of retail stores. And some of the corporate donors are Kimberly Clark, JCPenney, and Corporation A, which wish to remain anonymous throughout this presentation. And we're going to be talking about JCPenney and Corporation A. So the objective of our project was to improve efficiency with the processing of donations and other related items. Our project had 4 parts. The first part is processing steps and facility layout, processing simulation model, cost-benefit analysis for Corporation A, and a volunteer scheduling model. To start off, we're going to talk about processing steps and facility layout. We created 8 different categories of different items that are processed throughout the store daily. And so I'm going to show you an example of shoes. This is the steps that we generated to process a box of shoes that was donated. If a volunteer wishes to follow this image, they can do that, or they can use a more visual approach that we used a process flow diagram. And in this diagram, as you can see, start by opening the box, removing any tags from the shoes, deciding if the shoe has a pair or not, placing them into a basket truck, and then taking them to the facility layout, which is going to be shown now. This is a scaled down version of the facility layout. This is for the volunteer's reference to know where to place the items more efficiently. To start off, the items come in through the loading dock. The seasonal items are stored in this location. The items that are being processed are brought here to this area and then are processed in this location and then brought into the facility.
So next I'm going to talk about our simulation model describing the whole processing steps. Here is a video so you can have some idea of how the model looks like. So the entities will generate from a source of JCPenney, and we say that's closing here, and it will then go through 3 stations. The first is marking, and then checking, and then hanging or packing station. If the closing piece has any defects or it's not in season, it will go to the defect scene. Otherwise, it will go to ready scene, means it's ready to be sold in store. And then we also had models for Corporation A's sources. We call it the entities is miscellaneous boxes, and it only have 1 station. It's a Corporation A processor, but it also has 2 things. One is with defect, and the other one is without defects. So we also have some factors here affected our output. The first is the number of donations received. We say that's a copy of entities in our model. We got a number from the Excel sheet provided by the Volunteer Center. Then we had an estimation of the amount of numbers they received on each pilot or each boxes. And then we have the types of donations. So for the JCPenney one, we call it closing or type. Then we say the closing is 90% defect free and 8% in season. So if it has any defect or if it's out of season, we will have another time delay for that. And then for Corporation A, we say that's miscellaneous boxes, and it's also 90% defect free. And then we have the processing rate. So for Corporation A's processing, because we didn't have any data for that, we just went to the Volunteer Center and processed about 15 boxes and recorded our number rates. And for the JCPenney's rate, we watched a video of previous volunteers processing and used the software to match it to a statistics distribution. And then finally, we have the capacity of service. We say Corporation A. So next, Sophia will talk to you more about that.
Okay, so I'm going to talk to you about the third part of our project, which was a cost-benefit analysis of Corporation A donations. So we were asked to find out if these donations were actually being profitable or not. So the first thing we did was define a set of variables. So the first variable was average processing time per box. The next variable was average items per box. The other one was average price of the items in the box. And finally, the amount of boxes received. So, okay, I don't know, we're having a little bit of technical problems here, but the first equation that we used calculated the total hours needed for total worker hours needed for processing a donation. Then we calculated the total cost, the total revenue, and then finally we calculated the profit. And we used a beta distribution just to get a better fit for our model. So these are the variables that I talked about, and these are the values that you can change in our Excel spreadsheet. And then these would update the entire table. So as we can see, even in the pessimistic scenario, we would still be earning around $2,700. So we're saying that these donations are actually profitable. Next, we created a volunteer scheduling model. So the first thing we did was define the worker tasks needed any given day at the store. So with these tasks, we actually created our variables. So our main variables are going to be manager, cashier, processor, which takes into account all the different processing steps, and then miscellaneous. What we did was actually put runners and cleaners as part of miscellaneous, just because these tasks can actually change around during the day. So we don't want a person to be working just as a runner all day long. So our constraints are basically that we want runners and cleaners to work only on the first or last shifts, just so they don't get into the way of customers shopping at the store. Another constraint was workload variability. Since this is a volunteer center, the amount of donations received per week may vary, so we have to take into account that. And finally, our final constraint was partial rotation shifts. So this means that we have 3 fixed workers right now, and that's going to be our minimum amount of workers. And we actually also have rotating workers, which in this case would be the volunteers. So our main assumptions were that we're not taking into account breaks for either volunteers or fixed workers, and volunteers will be available whenever we need them. So this is what our model gave us as a result. We ran this using Excel solver, and what we did was from Wednesday through Friday, our store is only open 7 hours. So we divided it into 1-hour shifts, 7 1-hour shifts. And then as you can see in the orange line, the total volunteer hours needed are going to be 56. So when we ran the model, the amount of workers that we need to have any given shift is going to be 8 in order to satisfy these 56 hours. And then we ran it again for Saturday because the store is only open 6 hours, and in order to satisfy 54 worker hours needed, we're going to need 9 workers. So these results we used to create 3 different types of schedules. So our first schedule was a smooth schedule, which basically has an equal amount of processors every day. Then we have a start of week schedule, which has more processors at the beginning of the week, and it goes down as the week goes by. And we finally have a seasonal schedule, which increases the amount of workers at the store for peak sales periods such as Christmas or Thanksgiving. And this is what our schedule looks like, and this is just a close-up of any of the shifts.
So our final recommendations for the 4 parts, starting with processing steps and facility layout, we recommend that the Volunteer Center provides the processing steps that we created in an email or on their website or located in their store, so that volunteers can use that as reference to more efficiently process the items they are taking out of the boxes. For the process simulation, we recommend that the volunteers only focus on one task to increase learning curve and also have more volunteers working on hanging items. For the cost-benefit analysis of Corporation A donations, we recommend that BCMT Volunteer Center still continues to receive donations from Corporation A because it is profitable tier scheduling model, we recommend that they use the Excel sheets we provided depending on the number of donations that have come in. Thank you. Are there any questions?
Okay, great. Questions?
Yes. In your simulation, there was a timer running. What were the units of time? Was that?
It's our,
Okay, thank you.
Any other questions?
So what was the most challenging aspect of the project?
I think we could all say that it was getting data because we didn't have a lot of access to historical data. So we had to go out and actually record most of the data ourselves in order to build the models.
Which model was the best or the most fun to build?
I think for all of us, maybe the simulation model, just because it was kind of new for us too, and then who had a little bit of experience with it.
What was the language that you used there?
it's senior. Yeah.
Senior?
Yeah.
Okay, other questions?